Hello teachers, my name is John Paul Sorensen and I am a 6th grade teacher at Neil Armstrong Academy, and I am coming to you today to do a little bit of voluntary professional development, if you will. We're going to explore together how to take what is a fairly decent lesson and transform it into something truly spectacular and amazing through very little effort. As many of you know, the district is widely adopting the 2015 version of Go Math starting the next school year. I've been working with that now for a little while, and it's a good program. But remember that the Granite Way dictates fidelity to the core, not fidelity to the program. And so today, I'm going to go on a journey with you in which we will take a standard Go Math lesson as presented in the book, and we will transmogrify it through very little effort into something that is amazing.
Okay, so in order to transform a math lesson, I'm going to start by getting to the math lesson. So I've been granted access to all of Go Math. Mwahaha! Anyway, I could choose to do a lesson from any grade, but I think I'll pick 4th grade. I teach 6th grade, but I want to go outside of my comfort zone here, so I'm going to go to the teacher edition, and I'm going to browse a bit until I find something that looks interesting to me. Let's see. How about multiplying 2-digit numbers? That's normally a fairly dull thing to do. So I'll go into the lessons, and let's see, I'm going to do some, let's do multiplying with regrouping. Lesson 5. So here I go. And here it is. Now the first thing I'm going to do is make sure that I understand where I want to go. So the learning objective, use regrouping to multiply 2-digit numbers. So I want my students to multiply 2-digit numbers by the time I'm done. And if I look here, this is the core standard. I'm going to read it over, multiply whole numbers of up to 4-digit by 1-digit, and then multiply 2-digit numbers. Use strategies based on place value. Okay, so I'd like place value strategies. Properties of operations, and illustrate and explain the calculation by using equations, rectangular arrays, and or area models. So it looks like I've got a lot of thinking that needs to be done here. Now, what we would do if we were less inspired is we would go here and we would look at this lovely problem here with the Model T. It's an okay problem. I hate this. This is hand-holdy, and it's not going to help our students generate the kind of problem solving that we need to problem solve. We want them to focus on those practice standards. So let me see if there's any usable nugget here. 93 minutes to make a Model T. How long did it take to make 25 Model Ts? Well, it didn't take them 93 minutes to make one back-to-back, so that's a terrible question. I don't like it. So I'm not going to do that one.
Now I know that many of you out there are worried as you look at this and you're saying, I can't do that. I'll get fired. Please understand that this method is completely 100% de-rigged and approved. Sanctioned by the district. This is the way we are supposed to be teaching. The Granite Way specifically says fidelity to the core by identifying the essential concept and then helping students to get to that conclusion. We're doing exactly what we've been asked to do, only we're doing it in a way which is more awesome.
So I'm not going to do that one, and I'm not going to do any of these ones in the middle for right now. In fact, I'm going to do something that's a little bit crazy. I'm actually going to scroll down to the very bottom of the lesson to these guys down here. See these lovely story problems? This is where I want my students to start. Now that sounds weird. Why would you start at the end of the lesson? Well, the go deeper stuff and the deeper thinking stuff, it all happens down here. But who ends up doing those problems? Well, the smartest kids who get down to the bottom of the page. Our low kids never even get exposed to it. How are they ever going to develop problem solving if they never see it? So, yeah, we're going to skip all this stuff. We'll come back to some of it later. So let's look at these go deeper problems. I've got this one. This is summer camp cabins. That's kind of fun with some cots. There are 16 cabins. Each cabin needs 6 cots. Each cot needs 92. Now that's 3-step multiplication. So it's an okay problem, but it looks like it's maybe has a disconnect with my learning objectives. So I might use that one as a backup. Let's look at this one. The theater has 28 rows, 38 seats downstairs, and 17 rows and 26 seats upstairs. How many seats does the theater have? I like this. It's a 3-step problem, actually. It's going to involve some multiplication and some addition, so it might be a good backup problem again, but I don't want to start with it because it's not deeply tied to my learning objective. Let's go down to this Think Smarter. This is Garcia's class raised money for a field trip to the zoo. Ooh, the zoo! Everybody loves the zoo. 23 students in the class, $17 for each student. That's fairly simple. That's 23 times 17. This is what I want my students to tackle. So I'm going to modify this story problem, because if I just put it up here like this, it's kind of boring. First of all, we don't have any visual of the zoo, so we can't get excited about it. And second of all, Mrs. Garcia's class, who cares about that? Let's use our class. So I'm going to go and find a zoo or some other fun place to do a field trip. In fact, maybe, I don't know, where should we go? Let's go to SeaWorld. I love SeaWorld. Okay, so I'm going to go ahead and do a Google search here. SeaWorld, and I better specify in San Diego. Aha. SeaWorld San Diego. Aha. And I'm going to go straight to their website. And first of all, I need to know how much tickets are. So, where are my tickets? Get tickets. All right, now let's see. I want to take all of my students to SeaWorld. They're fourth graders, so they should still be of age. The adult child and the ticket, they're the same price. How lame is that? Anyway, so I'm going to grab this little piece of information for my story problem. I'm going to do it with a screen capture. How you do screen capturing will vary from computer to computer, but I'm just going to nab that for later. Chink. Okay, now I've got that. And now I need some pictures of SeaWorld that will make my kids interested in SeaWorld. And I'll just go to images, and I want to find a cool picture of SeaWorld. Or maybe a video of SeaWorld. Oh, look at that. Yeah. How awesome is that image? I'm totally taking that one. Save image. SeaWorld 6. That works. We'll save it right there. All right. And let's take one more picture of SeaWorld. I want something cute. Let's see. Where are the dolphins? Everybody loves dolphins. There's got to be a dolphin here somewhere. Time to search powerfully. Dolphins. Oh, yeah, that's better. Oh, that's heartwarming. Look at that. Okay. SeaWorld dolphins. Save. All right, now I'm going to take all this useful information and I'm going to throw it really quickly into a PowerPoint presentation. You can use PowerPoint, you can use Prezi, you could make a poster, you could just show the kids the pictures, you could do whatever you want. This part is entirely up to your craft. I just like doing this because it is easy. So the first thing I'm going to do is I'm going to get my kids excited about SeaWorld, and I'm going to put it up there. Yay! And let's make a new slide. My layout of my slide to be blank, and I want to put this one. Now, okay, so one of the issues that we have often with students, and particularly ELL learners, is that they don't attack story problems the way they should because they have reading issues. So I want to present this problem in such a way that everybody's able to attack it and everybody's able to go after it. So I'm going to make a new slide, and this is where I ask my question. And let me put my question as the title. How much would it cost for us to take a field trip to SeaWorld? I better capitalize SeaWorld. What's its issue with the spelling on SeaWorld? Oh, it's a capital W. Oh, very nice. And let's see, I want this lovely picture back down here to remind my kids of how fun that would be. And then the next part of my lesson is fairly easy. So we want to know how much it would cost for us to take a trip to SeaWorld. Now, we're going to ignore bus fees, we're going to ignore plane fees. We just want to know how much would it cost us to get in. If we could magically be transported to the gates of SeaWorld to take a field trip, how much would it cost us all to get in? And then we ask the most important question for our kids. Let me duplicate this slide. You ready? What information do we need? That's so important to ask that question, because this is where the problem solving begins. This is where this all starts out. We ask the students, what information do I have to give you in order for you to tell me how much it would cost to get into SeaWorld?
It's important to take a moment right now to remember a little bit about the core and fidelity to the core. Many people think that the core is the content. The content is a part of the core. But, and this is world rocking, the 8 practice standards, the standards for mathematical practice, these represent the heart of the core. These are the core. The content is the vehicle for getting to these. So we want to spend our time developing these through the content. We don't want to sacrifice these to get through the content in a timely fashion. That would be defeating the entire purpose of what we do.
World. And then the students talk about it. Do we need to know where SeaWorld is to know how much it costs to get in? Do we need to know all of those things? And hopefully they'll come to the point that we end up needing 2 pieces of information. And those 2 pieces of information are simply how many of us are going and how much is it going to cost each one of them to get in. So this is where my first picture comes back in. So, cost of tickets. And I pulled it straight off the website. There it is right there. San Diego SeaWorld, $69 value tickets right there. And it would cost them $69. And then at this stage, you let the students go. You give them some time to work individually to see if they can figure it out. Offer them manipulatives, offer them scratch paper, offer them models, offer them whatever they need in order to solve this problem. Give them about 10 minutes, 5 minutes working alone, and then maybe 5 minutes working quietly with partners or groups to come up with whatever solution they can come up with in any way that they can come up with it. And then as you have them working, you as a teacher roam around and look at their work and see what they're coming up with and see what they're thinking. And they'll come up with some amazing things. I'll bet you anything that as you watch them, you will see them, some of them anyway, make some equations. You remember our mathematical practices up here? I'll bet you'll see some equations. You might see something resembling a rectangular array. You might see something as an area model. You might see some repeated counting. You might see some repeated addition. These are all good problem-solving strategies for multiplication. And then let them go from there. Now what you want to do is, as you're having students share what's going on, maybe find some students who are using some of the multiplication algorithms that you've been practicing and have them share there. And then we are going to go back to doing a little bit tricky. We want to basically get back to this place right here, but using those numbers. Okay? So, back to my PowerPoint. Get a new slide, and eventually we want to get to the place where we have what? Let's say there were 25 students times $69. That's going to involve regrouping. There's going to be a lot going on there. Now this is going to take about 15 to 20, maybe even 30 minutes to go through with your students. And it seems like that's a lot of time to spend when you have so much to do. But if they're really engaged and they're really doing what they should be doing and working through this problem, once we get into the teacher section here, they'll be just cruising along nicely.
Some of you, as you are watching this, are worried that you will not have time to integrate this into your current teaching schedule. I want to assure you that it's all going to work out just fine. If you introduce your lesson with a challenge, you will be promoting conceptual understanding that will make the practice element of the lesson go so much more smoothly and so much faster that you'll end up making up the time plus some, and then you'll get to the end of the year with a whole bunch of students who know how to, think their way out of a wet paper bag.
All right, so now I've gone to the student edition of the book, and I'm going to carefully select the problems that I want the students to do. I don't have time to do all of them, and I'm trying to avoid this kind of hand-holdiness. I'd rather go through and do it with them. And so I'm going to pull this section here, which is the share and show section. I want to do these 4 problems for sure with them. So I'm going to nab those. And then I want possibly these 3 problems here. And then I probably want these 4 problems here for their own work. And then I'll go back to this problem to sum up because I really like it. Now you can see I haven't done all of the problems in the book. That's where we save the time that we lose on the front end with the challenge. We save it on the back end by just simply doing less practice. And the conceptual foundation understanding will help to make that so that, they don't need as much practice. So I'm going to go ahead and add a few new slides here. Oops.
Okay, now I know there's a lot of you out here who are saying, this is too much work. I can't do this. Please remember, you teach on a grade level team. And if you can convince and connive some of your grade level team people to work with you, maybe there's 3 of them, then you only really have to do this for 1 in every 3 lessons. You can share the other ones. That's a good idea. And as far as those who are worried about technology, technology is not essential. You can do this with paper, pencil, any way that you want to do. It's the methodology, it's the thought process that makes the difference. So don't let technology scare you away from the method. Do it in any way that works from you. And as you do it more and more, you'll become more comfortable with it. It will become more natural to you, and your general awesomeness will increase.
I want blank ones. New slide. I'm going to change the layout to blank. Yay. And now I'll add a few new slides. Okay, and now I'm going to grab the screenshots that I just took, and I'm going to throw them right here onto this PowerPoint. Ta-da-da! And there's those 3 problems. I'm going to do these with my students. So using the methods that we came up with in our discussion, we're going to do these 3 problems all together. Then I'm going to have them do these problems with their tables, and I'll check for understanding as they're working with their tables or in groups or in partners to make sure that all the students are getting it. And then we'll check these together as well after they've had an opportunity to work in small groups to complete them. And then I'm going to assign these problems as an on your own check. So they'll work these ones independently, and that will be able to give me some insight as to whether they do it. Now when I create these PowerPoints, I actually go into the teacher edition and get the answers. So I'm actually putting the answers up for anything that they do independently so that as they finish a problem, they can check their answer and then they can look for mistakes themselves. But you may choose to do that. You may choose not to do that. It's up to you. And then I'm going to close with this problem and really make sure that everybody has an opportunity to do this. It'll be another challenge, and we'll read the problem. We'll take it apart together. And this is basically my lesson. So it's just like a Go Math lesson. It's a simple Go Math lesson, but it's just been transformed just a little bit by looking at the backside first and trying to develop some problem solving and some deeper thinking skills, trying to engage students with a more interesting background, trying to help them grasp it and be more interested.
Thank you for hanging in there with me. I'm going to let you go now, but I'm going to leave you with this important thought. Now I'm going to wax serious for just a moment, so bear with me. There is a significant difference in this world between a chef and a cook. A cook prepares food according to a recipe that is given to them. It's a noble profession, and there's a lot to do. There's a great deal of technique involved. There are certainly good cooks and there are bad cooks. But what makes the difference between a cook and a chef is what the chef does with the ingredients. They improvise. They bring their own flair. They bring their own awesomeness to the table. We have been given the opportunity by the district to be, if you will, educational chefs. We have the opportunity to bring our students something that is truly special with fairly reasonable effort on our part. I fear that there are many out there who will be inclined to simply cook up Go Math as it is written and serve it. You could do worse things. The students will get a viable curriculum, they will be introduced to the core, but I doubt very much that they'll remember the experience for the rest of their lives. Let's be chefs. Let's do something special. Let's take this opportunity and experiment. Good luck, teachers.